Hello students, I am Mrs. Nadgouda, Department of Chemistry, KLS Gokte PU College, Science Section. We are continuing with the topic Electrochemistry. Today, we are going to solve some problems based on calculation of standard Gibbs energy and using even we will solve some problems based on Nernst equation and Kohlrausch law. So let us start with the problem. So first problem is calculate delta R G naught for the following reaction. The reaction is given Fe plus 2 plus Ag plus gives Fe plus 3 plus Ag. Here the values are given of E naught cell and F, that is Faraday. So this problem is asked in March 14 for 3 marks. So how to solve such problems? For this, first of all we should write the formula, and in that formula the required quantity, that is N, that we will see. So the required formula is delta R G naught is equal to minus N minus NF E naught. Out of this, E naught and F values are already given. So how to take N value? So in the above reaction, Fe plus 2 is getting converted into Fe plus 3. That is, there is a loss of 1 electron. Hence, N is equal to 1. Now, by substituting this value in the above equation, we will get the solution, that is the final answer. Okay, let us see next. So N is equal to 1. The minus sign will remain as it is. 1 into 96,500 coulomb into 0.03, that is E naught cell value. So final answer comes as minus 2895 joule, or if you want to convert it into kilojoule, divide by 1000. So it will be minus 2.895 kilojoule. But conversion of kilojoule is not compulsory. This problem is asked for 3 marks. Now 1 mark is given for the first step. 1 mark is given for this step. 1 mark is for substitution, and 1 mark is for final answer with proper unit. Fortunately, I got the supplementary exam question paper of 20, that is September 20, and in this again the same type of problem is asked. The cell in which the following reaction occurs, the reaction is given, has E naught cell value 0.236 volt at 298 Kelvin. Calculate the standard Gibbs energy. Here also F value is given, but see students, the value is 96,487 coulomb per mole. It is not 96,500. So whichever value is given in the question paper, same value you have to take when you are solving the answer. So let us see again the same formula. Delta R G naught is equal to minus NF E naught. Out of this, E naught cell value and F value are already given. So just we have to take N value. Now in the above reaction, if you see, 2Fe plus 3 gives 2Fe plus 2, or 2I minus and I2. So here there is a change of 2 electrons, and hence N is equal to 2. So by substituting N is equal to 2, we will get the further solution. So minus sign will remain as it is. 2 into 96,487 into 0.236 volt. So the final answer comes as minus 45,541.86 joule. Again, if you wish to convert it into kilojoule, you have to divide it by 1000. So it will be 45.54186 kilojoule. Let us solve the next problem. Calculate the EMF of this cell. Now we have to calculate the EMF of this cell, that is E cell. Now E cell, to calculate E cell, we have to use Nernst equation. Already in last class, we have solved two problems based on this. Again, I have taken one more problem which is asked in March 15. So given values of individual cell half cells, that is Mg plus 2 Mg and Ag plus 1 to Ag. So this cell values are given. Then the concentration, molar concentrations of Mg plus 2 ions and Ag plus ion is given, and it is in the form of 0.001. So in 10 to the power form, it will come as 10 to the power minus 3. This is for first one, and for second one it will come as 10 to the power minus 4, right? So by taking these values, we will solve the problem. Let us see the solution. So here the formula is E cell is equal to E naught cell minus 0.0591 divided by N into log of molar concentration of product and divided by molar concentration of the reactant. So here the product Mg plus 2 ions are present, and hence we have to take 10 to the power minus 3 concentration in the numerator, whereas in the reactant Ag plus ions are present, and how many moles are there? 2 moles are there. Therefore we have to take the square of this 10 to the power minus 4. So again by substituting all the values. Now here E naught cell value is not given directly, so we have to calculate first. So which formula we can use? E naught cell is equal to ER minus EL. Now ER means right hand side, and for this now you must need to write the cell. So how to represent the cell here? We can write the cell as Mg, then Mg plus 2, double vertical line Ag plus 1 and Ag. Now why we have to write this? Because Mg is converted into Mg plus 2, that is loss of electrons, and hence it is oxidation. So oxidation always takes place at anode, and anode we are writing it on left hand side. So first represent the cell, so you will come to know which is the left hand side electrode and which is right hand side electrode. So according to that, now which is the right hand side electrode? Ag plus 1, that is molar value of E naught of Ag we have to take it first, and then left hand side is Mg, that is magnesium electrode, and hence we have to use these values to calculate E naught cell. So 0.80 minus of 2.37, so it will be minus becomes plus. Now the total answer will be E naught cell is equal to 3.17 volt. Now substituting this value of E naught cell in the formula, we will get the next step, that is E cell is equal to 3.17 minus 0.0591 divided by 2 into log of 10 to the power minus 3. As I have told you, I have converted these values which are in decimals into 10 to the power. So 10 to the power minus 3, that is the magnesium concentration, and 10 to the power minus 4 is Ag ion, that is silver ion concentration. Now as the number of moles are 2 of Ag, we have to take the square of this. So 10 to the power minus 4 into 2, it will be 10 to the power minus 8. So this in denominator it will become 10 to the power minus 8. Now when it goes to the numerator, it will become plus 8. So 10 to the power minus 3 plus 8 will become 10 to the power plus 5. So let us see the next step. 3.17 minus 0.0591 divided by 2 into log of 10 to the power 5. Now this value is already given. Therefore, substituting the value of 10 to the power log of 10 to the power 5 is equal to 5. We will get the next step, and the final answer will be 3.0225 volt. So again this problem is asked for 3 marks. 1 mark for first writing the formula, 1 mark for calculation of E naught cell and 1 mark for the final answer. Let us solve another type of problem which is asked in July 17. So lambda naught M for NaCl, HCl and CH3COONA, that is sodium salt of acetic acid, are 126.4, 425.9 and 91.0 Simon centimeter square per mole respectively. Remember the word respectively. Calculate lambda naught M for CH3COOH, that is acetic acid. Now what is meant by lambda naught M? That is limiting molar conductivity. So whenever the word limiting molar conductivity comes, we have to apply Kohlrausch law. Now before application of Kohlrausch law, we should write whatever is given. So first write down the values which are given one by one, because the word is used as respectively. Then according to Kohlrausch law, we should write lambda naught CH3COOH is equal to lambda naught CH3COONA plus lambda naught HCl minus lambda naught NaCl, because according to Kohlrausch law, the limiting molar conductivity of any substance is equal to the individual limiting molar conductivity of individual contribution of cations and anions. So by application of this, we can solve the value, we can calculate the value of lambda naught acetic acid. So by substituting all these values, we will get the final answer. So the final answer is 390.5 Simon centimeter square per mole. Remember this, remember students, whenever you are solving the problems, always you have to write the proper unit. Without unit, there is no mark for the answer. So you will lose 1 mark for not writing, just not writing the unit. So please do the practice of writing the unit. Now, I have given some problems for practice which are similar and which are appeared in the previous year question papers. So, here are the problems. Calculate the EMF of this cell. Here E naught cell value is given already. So, and molar concentrations are given of Ag ions and nickel Ni ions. So, you have to apply the Nernst equation for this, and this problem is asked in July 15. Then second one, find the value of delta G naught for the following electrochemical cell. Now in this electrochemical cell, you have to first write the equation and then solve the problem according to delta G naught is equal to minus NF E naught. Why you have to write the reaction? Because you should know what is N, what is the number of electrons in that. Then the electrode potential for the Daniell cell is given. Write the overall cell reaction. Now here the marks, 3 marks are given to write first the reaction, then calculation of standard Gibbs energy. So see here, F value is given as again 96,487 coulomb per mole. This problem is asked in March 17. So whichever is possible I have already taken. And if you want extra, please solve the previous year question papers, or I will give you the link. Through that link you will come to know what are the extra questions and which type of questions will be asked in the exam. So this is the link. Through this link you can you will come to know how the questions will be asked, and any extra problems, if they are there, you will come to know. Thank you.